Alright, so here goes my second video on how I do what I do, basically. This one is about the AI system in my space game, because some people asked me about it, and, well, I just thought I'd make a video on it. So, the basic thing is my AI ship class, which inherits from the usual ship class and just adds all the AI functionality. Basically, the update function just does the base update and updates the AI module and fight module, and there are some wrappers which basically just redirect to the AI module, but it's private, so I kind of need them. I could make it public, but I like this way better somehow. Alright, so this is kind of messed up because I changed quite a bit recently and I did not bother to clean it up. Okay, so here are just add command systems, functions, methods, whatever. And they use AI commands, which is basically the main thing. The AI module just wraps stuff for the root command and kind of works as a tree handling method, because the AI command structure is a tree structure. Each AI command has subcommands, and the execution works like each command executes the first active subcommand it has. A command can have one AI command status. Oh god, where is it? Here. Which can be waiting, active, done, and aborted. Usually when a command is done or aborted, it is removed immediately, but it's just nice to have them in case something goes wrong. So, well, here the AI command is, this is kind of a virtual class. You can see most of the methods are virtual, because in my AI command management I have several classes inheriting from it, and what they do is basically implement the action that the AI does in whatever instance of a command it has. Like the root command, which is for basically every normally spawned ship, the root command of the command tree just adds the lure root command and is done with it. So this is kind of the most important class for my AI. This is just a constructor. You can do it whatever way you want. I did it with passing strings that are split up into the command body and parameters. And here is the termination response. Every command gives a termination response on update, which means when... where is it? Where is my update? Seriously, where is it? There has to be an update function. Oh, there it is. Okay, so this calls the lure command. Each command is split up in body, parameters, and end, because every lure function or Lua AI function expects to get the command ID and ship ID that it is called from at the end of the function call. I will show you. It looks like this. Oh well, it's a mess. Anyway, each call to a Lua AI function uses cmd, ship ID as the end of the function call. So you will know which ship called it and from which position in the tree. So you can append commands or remove the command that was executed. This is just so I can see it in debugging. Well, for each command, when it is activated, which means its state changes from waiting to active, its onActivate event is called. While it runs, update is called, and terminate. For hard-coded commands, basically command update returns terminate. And for the Lua commands, it's two separate functions, but the hard-coded wrapper to it basically just does the same thing. There are three kinds of termination response: no termination, success, and aborted. But because this is scripted and every script execution has its own thread and it's not really thread safe here, I have to be quite error safe here. So if I get another value or no value at all, I just terminate the command. If it was an important command, it will be executed again. If it wasn't, who cares? That's how it works. It's not very beautiful, but it kind of works. So the Lua commands are not meant to be executed each frame, because that would be way too expensive. They're just there to make decisions somewhat, so you can easily change it. And they make up more complex commands out of subcommands and just add them to themselves as subcommands, which means the subcommands will be executed but not the actual Lua command. And when the subcommand terminates, either the next subcommand will be executed or the subcommand that was or the command itself will be called for its update and termination method. So either it can add new subcommands to accomplish its goal, or it can terminate and return control to the next parent node of the command tree. I guess I talked enough. So basically I can set up my AI however I want. On my startup I call this Lua file, which sets up each of the commands I have. It's not very beautiful really, but I'm just trying to illustrate the system here. So the root command just on activate adds the standby command, and it initializes itself as the root command, so I know I know where the root command or the Lua root command of this ship is. This is what this line does. Well, so next my standby command, it on update, which is basically every frame when it is in control and has no subcommands, it will it will add a new subcommand to itself, which flies to a random position, which within a range of 2,500 units. And here is the event handling part. When an event occurs, for the last active command in the command tree, the react whatever part is executed. For hard-coded commands, it's react and react to message, which just receives the message. For Lua commands, it is react and whatever the first part of the message is. I'm doing this with strings. Maybe it's not really neat